In this video, we will introduce loop logic. Alright, so loops are used to help avoid having to implement the same logic more than once. So the rule of thumb in programming is if you have to do something more than one time, either create a loop to do the work or put it in a method. And we will get to methods later. But loop logic helps us do work repeatedly. Generally, loops fall into two categories or patterns. The first is the Sentinel controlled loop pattern. So whenever you have a loop that you do not know how many times you need to loop, this falls under the Sentinel control loop pattern. So for example, if you had to write a program that prompted the user to enter in a password, and every time the user got the password wrong, you would reprompt them, this would fall into a Sentinel controlled loop pattern, because we do not know how many times it would take the user to enter in the good password. Maybe they get it right on the first try, maybe they never get it right. So we do not know ahead of time how many times we need to loop. The second type of pattern is the counter-controlled loop pattern, which we can use when we know exactly how many times we need to loop. So if we have to do some piece of work 12 times or 100 times, or if the user enters in a value and we need to do work that many times. When you know how many times you need to do the loop, a counter-controlled loop pattern will work for setting up the loop. Let's compare the single condition logic of an if statement to the loop logic. In the single condition in the single condition logic, what we do is we go down and we check some conditional expression to see if it is true or not. If the expression is true, we do a little bit of extra work. If the condition is false, we just go along with our program. We can implement this single condition logic using an if syntax. So the syntax in C# is if, keyword if, parentheses, some conditional expression, and then we have a code block attached in which we write all of the statements that execute the work we want to do. If this condition evaluates to true, we execute the code block. If the condition evaluates to false, we skip the code block and go on with our application. Now let's compare this to the loop logic. In the loop, instead of once we're done doing the work, continuing on our way, here when we finish doing the work, we go back up and test to see if the condition is still true. So we test a condition. If it is true, we do the work, and then we retest the condition. And we keep doing this until the condition is false, at which point we can go about our business. So the syntax to implement a loop, a simple loop like this, is the while syntax. And the while syntax looks exactly like the if syntax, except we use the keyword while. So while some conditional expression is true, we attach a code block, and inside the code block we have all of the statements that implement the work we want to do. The difference between the if syntax and the while syntax is if this condition is true, we execute the code block, and then we go back and recheck to see if the condition is still true. If it is still true, we execute the code block again, and this forms our loop. Now once this conditional expression evaluates to false, we skip the code block of the while loop and then go about our program. So let's do a very quick example illustrating this. So here I'm going to create a very simple single conditional expression. I'm going to make a variable named x which holds a value, and I'm going to build a conditional expression. If x is less than 10, then I am going to print console.writeLine x is less than 10. Now since we set x equal to 1, 1 is less than 10, so we should see the statement x is less than 10 printed one time. Let's run this. And here we see x is less than 10. It is printed one time. Now let's just change the if statement to a while statement. So all I'm doing is changing the if keyword to the while keyword. And let's run this and see what it looks like. So in this example, we are printing x is less than 10, and we are continuously printing this. It's hard to tell on this console window, but it is continuously just spamming x is less than 10 forever. So while the syntax is very easy to implement, a loop is very easy to implement in C#, implementing a good loop takes a little bit more effort. So let me break this program here, and we'll go back to our notes. So what I'm going to present here is a 4-step plan to always building a good loop. Okay, there are many ways to build loops. You do not have to follow the 4-step plan, but if you have these 4 steps in this order, you will always build a good loop. It doesn't matter if you are building a Sentinel controlled loop or a counter controlled loop, all good loops can follow this pattern. Alright, step 1. What we're going to do is we're going to initialize some conditional variable or variables before we get to the loop condition. And so in our flowchart logic, I've modified it to kind of have these 4 steps inside it. So we come down here before we check the condition, and we are going to initialize our conditional variables. Now, what is a conditional variable? A conditional variable is the variable that is controlling whether the condition is true or false. So for example, when we were asking prompt the user to enter in a password value, and if the password is correct, to let them in, otherwise tell them to keep entering a password. Well, in this case, the password variable would be the conditional variable, because the value stored in password will determine whether we continue looping or not. Alright, step 2, we are going to build a loop condition. So for example, keep looping until what condition, or I'm sorry, keep looping while what condition is true. So in our password example, we would want to keep looping while the password was not correct. Alright, step 3, we are going to do some work inside the loop. Now, step 3 really isn't part of building a good loop, but all good loops should have work inside them. So work needs to be inside the loop body. It's not really tied to, it doesn't have to be tied to the logic controlling the loop, but it needs to be there. And then finally, the toughest one that I see new students struggle with when building good loops is the update statement. You need to update the conditional variable or variables before you get to the end of the loop body. So inside our loop body, the last thing we do, we need to update our conditional variables. The reason we need to update our conditional variables is if we initialize our conditional variables to some state and they give us the condition, or they evaluate to the Boolean value true, then we are stuck in this loop forever until that conditional variable changes. So having the update statement as the last thing we do inside the loop allows us a chance to finally reach a false condition in which we can escape the loop. So again, you don't have to follow these four steps, but if you do, then you will always build a good loop. And in the following videos, I will give several examples building loops, and in every one I will try to follow these 4 steps. Now, one last thing I will say before ending this video is you don't have to build the 4 steps in the order that I have them here. Quite often it is easiest when building a loop to just decide what is the loop condition. I want to loop while the password is not true. I want to prompt while the user input is a bad value. You know, I want to keep looping while some condition is true. Once you build the loop condition, usually you identify the conditional variable, then you can go and initialize it, build an update statement, insert the work.